As we draw to a close in this module, we've covered a lot of content about the options pattern. I hope you're suitably convinced that this pattern is a great way to access configuration in your applications. One question that you may have left though is how best to unit test classes which are dependent on iOptions of t, iOptions snapshot of t, and iOptions monitor of t. In this demo, we'll address exactly that by looking at several approaches we can use when testing classes that rely on any of these interfaces. We'll first look at a helpful factory method that we can use to create instances of iOptions t classes during unit test arrangement. We'll then look at achieving the same goal using a mocked instance. We'll also learn how mocking can be used with iOptions snapshot and iOptions monitor. And we'll conclude by reviewing a technique that uses a service provider during test setup instead of mocking. There's no one-size-fits-all solution for all unit tests. This clip is designed to give you several options that you can choose from depending on your scenario. The Club is Open rule class defines an individual court booking rule within the tennis court booking system. It depends on an iOptions of club configuration. In its complies with rule async method, it applies some basic logic to assess whether a court booking meets the rule and that it must start and end within the club's opening hours. We want to ensure that this logic works as expected. I've begun working on an initial unit test for the method within an XUnit project. This first test is designed to ensure that the complies with rule async method returns true when the booking start and end times are within the club's opening and closing hours. I'll uncomment the work in progress code. Immediately I've run into a problem. Since the Club is Open rule class, the subject under test depends on an iOptions of club configuration, we need something to pass into its constructor argument. We'll use a helpful factory method exposed on the static options class to create the iOptions instance we need. The create method takes a generic options class instance as an argument, so we can pass a new instance of club configuration here with the properties set with appropriate values for our test. Note that we only need to set the properties that we know are used within the subject under test. We can now pass this instance into the constructor for the new Club is Open rule, which means that this test now compiles. And that's one way we can set up tests for a class which depend on iOptions. Another is to use mocking. If I uncomment the code in this second test, we'll see how we can use mockq to achieve a similar outcome. This test validates that a booking which ends after the club closing time will fail to comply with the rule. As before, I've nearly completed the test. In this test project, I have referenced a NuGet package called mockq. This popular mocking framework can be used to create mocked versions of dependencies. I'll use the mockq library this time and create a new mock object representing the iOptions of club configuration. This requires a using directive for the mockq namespace, which is already included in this file. With mockq, we can call the setupGet method on the mock to set up the getter for the value property. We can define its return value so that it returns a specific instance of club configuration. We can create a suitable instance of club configuration as we did in the previous test. With the iOptions mocked out, we can pass the mocked object instance into the constructor of the Club is Open rule class. We can run the tests in this class to ensure that they pass. For iOptions snapshot and iOptions monitor, there are no convenience methods available to create instances, as we saw with the options.create method. In those cases, when unit testing dependent classes, mocking is a good approach. Here is the cached weather forecaster class which we'd like to test. It depends on iOptions monitor. It's also using the named options feature, calling the get method to retrieve the weather API named options. Let's see how we could unit test this class. Here in the cached weather forecaster test class, I have prepared two unit tests which I'll now uncomment. In this first test, I've relied entirely on mocking using mockq. Each of the dependencies is mocked, including the iOptions monitor of external services configuration. This time, I've configured the mock so that when the get method is called with the Weather API string, it returns an instance of external services configuration with the mins to cache property set with a value of 101. I'm using a feature of mockqueue in this test, which lets me run a callback on my cache mock that sets a variable with the value passed to the setAsync method of the cache. I can then assert that after calling getCurrentWeatherAsync on cached weather forecaster, the setAsync method has been called on the cache, and that it has the correct minutes to cache being provided from the named options instance. I appreciate this is quite complex code and there's quite a lot of setup going on in this test, but the main point is that mocking the iOptions monitor for named options is possible. Finally, you may prefer this other approach to create an iOptions monitor instance for your unit tests. This approach relies on stubbed instances of the cache and the weather forecaster types, which makes the test setup cleaner. For the iOptions monitor instance, we can create an instance of that by establishing a temporary iService provider. We first create a service collection. Then we call the configure method, just like we've used in the program file, to register an options type. In this case, rather than passing in the iConfiguration section containing the configuration to be bound, we use an overload which lets us provide an action delegate with an external services configuration instance that we can modify. Here we're setting the mins to cache property with a test value of 101. We chain a call to the build service provider method, which returns an iService provider instance, and from that instance we can request an iOptions monitor of external services configuration from the service provider by calling the getRequiredService method. We can pass that iOptions monitor instance into the cache weather forecaster constructor along with our stubbed classes. You can use various approaches to arrange unit tests when testing classes depending on any of the options interfaces. Options.create is a quick and clean approach when you depend on iOptions of T. Mocking is a good choice for iOptions snapshot of T or iOptions monitor of T instances, although the service provider approach is also relatively clean and simple. In this module, we've covered a lot of ground, so let's take a moment to summarize what we learned. We learned that the options pattern can be applied in ASP.NET Core, and that it's available by default in ASP.NET Core applications created from the templates. The options pattern provides a mechanism to bind configuration to strongly typed options classes accessible via dependency injection. We began by creating strongly typed options classes to hold groups of related settings. We then registered them and bound them from the configuration inside the program file. We used 3 different interfaces to access the options at runtime: iOptions, iOptions Snapshot, and iOptions Monitor. We compared when and why we'd choose between these different interfaces. We looked at using named options when multiple discrete configuration sections have a common structure. We applied options validation to ensure that the configured values were valid, and learned how to ensure that validation occurred at startup by registering configuration using the add options method. We concluded by exploring a few techniques that support writing unit tests for classes which depend on the options interfaces. Join me in the next module where we'll learn about working with configuration providers, a feature that allows us to define configuration in sources other than JSON files.